Hey everyone, have you ever really stopped to think about the magic that happens in those few seconds between pressing the power button and seeing your Linux desktop pop up? Today, we're going to pull back the curtain on that entire process, and we're going to frame it as a super high-speed relay race with 4 key players.
I mean, seriously, think about it for a second. You hit one button, the screen is black, and then, poof, everything just works. But how? What's going on in that quiet moment to bring an entire complex operating system to life? Well, that's the mystery we're going to solve right now.
To get our heads around this, we're going to follow 4 runners in this digital relay race. First up, we've got the first responder, the one who wakes everything up. Then, the gatekeeper, who finds the right path forward. After that comes the brain, which is, the core of the whole operation. And finishing the race is the manager, who puts all the final pieces together. So, let's meet our first runner.
And they're off. The first leg of our race is run by the player we're calling the first responder. In the real world, this is your system's BIOS or UEFI. Its whole job is to be the very first piece of software on the scene and get the computer's most basic hardware ready for action.
Right. So before Linux can even think about starting, this super fundamental bit of software has to wake up the essentials. It's the initial spark, the thing that pokes the keyboard, the screen, and the storage drives and says, all right, time to get ready for the race.
Now you'll see one of 2 names here, BIOS or UEFI. BIOS is the old school system. It's been around forever, but it's got limitations, like it can't handle hard drives bigger than 2 terabytes. UEFI, on the other hand, is the modern replacement you'll find in pretty much any new machine. It's faster, way more flexible with huge drives, and it packs in some really important security features.
Okay, so before our first responder can pass the baton, it has one absolutely critical job, the power-on self-test, or post. You can think of this like a quick team huddle before the race. It rapidly checks all the hardware players to make sure they're present and working. If everything's good, we move on. If not, you get an error message. With that hardware check complete, the BIOS or UEFI has finished its part of the race. It's found the next runner in line, the bootloader, and it smoothly passes the baton, trusting it to carry the whole process forward. All right, baton's been passed, so who's running the second leg? This is our gatekeeper, which you'd know as the bootloader. Its mission is laser-focused and absolutely critical. It has to find the front door to the operating system.
And that's really its whole job. It acts as a guide. It scans the hard drive, finds the Linux kernel, that's the very core of the OS, and then it physically loads that kernel into the computer's RAM, getting it all warmed up and ready to take full control.
Now, you might occasionally hear about an older bootloader called Lilo, but honestly, the star of the show these days is GRUB 2. It is the standard for a reason. It's incredibly powerful, it's what gives you that nice menu to choose between Linux and Windows if you have both, and it's just packed with features. So where does this gatekeeper actually live? Well, that depends on our first responder. On an older BIOS system, it's tucked away in the master boot record, which is this teensy tiny space at the very beginning of the hard drive. But on a modern UEFI system, it gets its own special place, a dedicated partition just for the boot files. And just like that, the gatekeeper has done its job. The path is clear. GRUB 2 has found the kernel, loaded it into memory, and now it passes the baton for what is arguably the most important leg of the entire race. It hands over complete control to the brain of the operation. And here we go. We're now with our third runner, the absolute heart and soul of the system, the brain, which is, of course, the Linux kernel itself. The second it gets that baton, it immediately takes command of everything. So what are its first moves? Well, fun fact, it's actually stored in a compressed format. So the first thing it does is unpack itself into memory. Then it does its own, much more detailed check of all the hardware and starts loading the essential drivers it needs to talk to everything. Its final critical act is to kickstart the very first process that will build the world you and I see.
So the kernel's initial setup is done. It has established total control, but it can't build the entire user environment by itself. For that, it needs to pass the baton one last time, to the manager who's going to assemble everything else. And that brings us to the home stretch, the final leg of the race, and our fourth player, the manager. In the Linux world, this is a process called systemd. This is the one responsible for building pretty much everything you actually see and use. Systemd is the modern way Linux systems start up. It is the very first process kicked off by the kernel, which makes it the official ancestor, the parent, of every other single process that runs on your system from this point forward.
And you've got to see its to-do list. I mean, look at this. It mounts your hard drives, it starts up the networking so you can get online, it gets the sound working, it handles the login screen, and then it loads your entire graphical desktop. It is one seriously busy manager.
So how does it know what to do? It uses this concept called targets. You can think of these as different goals for the system. For most of us on a desktop, the goal is the graphical target, which tells systemd to start everything needed for a full graphical interface. A server, though, might aim for a different target that only starts up the command line tools.
And with that, our final runner crosses the finish line. The manager, systemd, has successfully built the entire environment. The incredible relay race that started with a simple button press is finally complete. The login screen appears. So, let's do a quick instant replay of that race. Power on. BIOS wakes up and checks the hardware. Then it hands off to the GRUB2 bootloader, which finds and loads the kernel. The kernel takes control, sets things up, and hands off to systemd, which starts all the services and finally brings you to the login screen. 4 players, 4 perfect handoffs. When you really stop and think about it, it's truly amazing. All of that happens, from a single button press to a fully functional, complex system in a matter of seconds. It really is a perfectly choreographed relay race happening invisibly every single time you boot up.
So, I'll leave you with this to chew on. Now that you've seen the 4 stages of the race, what part of this hidden, high-speed process do you find the most surprising? Is it the initial hardware check, the bootloader's search for the kernel taking control, or the manager building everything at the end? Pretty cool stuff. Thanks for tuning in.